Welcome to this explainer. Right now, there's a massive transformation happening right under our noses. Or actually, scratch that. It's happening right inside our cars. We are literally in the middle of a modern digital gold rush. And the crazy part? The gold isn't in the engine block anymore. It's entirely in the software.
Okay, let's dive into this. We are witnessing a truly historic shift here. The mechanical era, the days defined strictly by hardware, internal combustion, and thousands of complex gears, that's rapidly giving way to the software-defined era. It's wild to think about, but today's vehicles, they're essentially just rolling computers, completely driven by AI, embedded systems, and incredibly futuristic digital cockpits. To put the sheer scale of this shift into perspective, just think about this staggering number, $40.49 billion. That is the projected value of the in-vehicle infotainment market by the year 2032, and it's scaling up so rapidly from an estimated $23 billion in 2025. So yeah, this isn't just some fleeting trend. This is an absolute economic explosion, completely fueled by our demand for connectivity, entertainment, and of course, those next-level safety features.
And this brilliantly illustrates exactly where all that immense capital is flowing, directly into next-generation digital cockpits and AI-based monitoring. The biggest tech giants are pouring massive investments into this space. We're seeing Harman rolling out their ReadyCare AI for in-cabin monitoring. Panasonic is pushing Snapdragon-powered augmented reality navigation. Alps Alpine is building next-gen compact human-machine interface modules. And Bosch, they're creating centralized computing platforms running on just a single system-on-chip. The scale here is just mind-blowing.
But here's the catch. All of this rapid innovation creates a serious choke point, something we can call the software bottleneck. See, because cars are now completely software-defined, they rely on dozens of complex electronic control units, or ECUs, to manage everything. Powertrain, entertainment, safety systems, you name it. Now, when code fails on your laptop, well, it's annoying, right? You just restart. But when code fails in a moving car at 70 miles an hour, that is a critical safety hazard. Absolute flawlessness isn't just a nice-to-have anymore, it's absolutely required for passenger safety.
So that brings us to a really critical question. Who ensures this software actually works? All these booming corporate investments and billions of dollars in market value, they mean absolutely nothing if the systems crash. So all this massive market data points directly to a massive human need, the automotive systems test engineer.
Now, to understand what these system test engineers actually do day to day, we first have to understand how a car's brain communicates. Meet the CAN network, or Controller Area Network. The best way to think about this, it's kind of like a standard computer network connecting all the laptops and printers in an office building, but built specifically inside a vehicle. Multiple electronic control units are all communicating over a shared central wire. But unlike your office network, the CAN network actually prioritizes critical driving messages, like, say, telling the brakes to deploy, over the less critical stuff. Plus, it has built-in error detection to ensure total stability.
So the crucial point is, how do you actually test a network this complex and this critical? Obviously, you can't just guess. You need specific industry-standard tools to mine this automotive gold rush. And the company Vector is definitely one of the most recognized names providing this specialized toolkit. Let's explore the actual software these test engineers are using every single day.
First up is Vector CANoe. You can think of this as the absolute ultimate sandbox environment for automotive engineers. It supports multiple protocols, things like CAN, LIN, and Ethernet. But its true superpower, it allows engineers to completely simulate a vehicle's entire network under real-world conditions without even needing a physical car in front of them. You can simulate real-time traffic, you can isolate and test individual ECUs, and you can perfectly visualize these super complex network interactions right there on your computer screen. It's a total game changer.
Let's move on and see how this builds. So while Vector CANoe serves as your simulation sandbox, CANalyzer is your real-time diagnostic powerhouse. It actively monitors live data exchanges across the network. It analyzes signal delays, tracks down errors, and reads and clears diagnostic trouble codes, or DTCs. It even allows for interactive debugging. This means you can adjust parameters on the fly and instantly observe the changes in the network's behavior as they happen.
But let's be real. Physically testing every single possible scenario in a car manually, that's completely impossible. And that is exactly where CAPL comes in. The CAN application programming language. This right here is the automation secret weapon. It's a specialized C-like scripting language used entirely within these Vector tools. It lets you automate incredibly complex testing scenarios, which basically frees up engineers to focus on higher-level problem solving rather than doing repetitive manual checks.
Let's demystify this highly technical process for a second. CAPL actually works on a very simple, event-driven programming logic. Step 1 is the event handler, which gets triggered by specific network signals. For instance, when a message is received on the bus. That automatically triggers Step 2, the function, which performs a specific task, like sending back a response message. Finally, Step 3, the control structure, executes conditional logic like loops or timers. This simple logical flow, it's the exact backbone that makes automated automotive testing possible.
Okay, so all of this incredible technology leads us right back to you, the viewer, and the current hiring landscape. Because who is actually looking for these highly specific skills right now? Well, the answer is basically everyone in the automotive ecosystem. We're talking original equipment manufacturers like Mercedes-Benz and Tata. We're talking Tier 1 suppliers, the guys building the complex parts like Bosch, Continental, and Delphi, and major tech consultants integrating the software like HCL and L&T. Every single one of them is actively hunting for system test engineers.
Now, what's really interesting here is the immediate demand. A quick glance at platforms like Indeed reveals over 300 immediate vacancies right now, specifically just for automotive infotainment testing. And remember, that's just one tiny niche within the broader, massive field of automotive systems testing. The demand is incredibly immediate, and it's widespread.
This brings us to a pretty powerful realization, captured perfectly by this quote. The automotive electronics industry is one of the major recruiters of software engineers in the world. If you're a recent graduate, or maybe a software engineer looking to pivot your career, you really don't have to figure this out alone. There are structured, hands-on training courses out there from expert institutes like ANSEAT and Multisoft Systems, and they're readily available to teach you the fundamentals. We're talking CAN networks, Python, and the exact vector tools we just covered. You can learn these exact skills and break right into this lucrative field.
So we end this explainer with a final question for you. Are you ready to pivot into the driver's seat of your career? The software-defined vehicle is undeniably the future of transportation, and the industry desperately needs skilled testers to ensure that future is safe, functional, and completely flawless. The tools are out there, the targeted training is readily available, and these companies are aggressively hiring. Thanks for joining me to uncover the hidden gold rush of automotive testing. Now go out there and explore this fascinating landscape for yourself.